Hello and welcome to Dr. Jim's Structures class, where we do structures by example.
Man's practicing fuzzy math again.
We all know that structural analysis can seem counterintuitive and confusing. It's Dr. Jim's mission to help you make sense of it. So let's get to it. This video is part of a series of videos on axial force, shear force and bending moment diagrams. The first problem we analyse concerns this simply supported beam. The beam carries 2-point loads, it has a knife edge support at A and a roller support at C. This video is the third part of a video mini-series covering different aspects of the solution. In the first part of the series, we found the beam reactions. We did that by cutting the beam away from its supports using a free body diagram bubble, a genius device used to isolate part of the structure to be analysed. The purple lines represent the cuts made, and these cuts expose the unknown reactive forces. If all this makes little sense to you, then click on the link on the screen to find out more about free body diagrams, free body diagram bubbles, and all sorts of cool stuff. Okay, back to the reactions. The next step is to apply the equations of equilibrium to the free body to find the reactions. If you want to see the details of how we did that, click on the link on the screen. In the second video of this mini-series, we set up algebraic expressions for the internal forces in the beam. You need to know how to do that, but gosh, it was hard work. That video finished by showing how axial force, shear force and bending moment diagrams can be used to represent these internal forces. If you want to watch the video showing how we did all that, click on the link on the screen. This video takes things up a level by presenting a quick, easy and foolproof way to go about drawing axial force, shear force and bending moment diagrams. It's the way a structural analyst would do it. We're dealing with a plane structure, so there will be axial force, shear force and bending moment in the beam. And we're going to need a sign convention. Dr. Jim's sign convention regards tensile axial forces as positive, shear forces that try to spin the element counterclockwise as positive, and bending moments that put the top face of the beam into tension are regarded as positive. In other words, hogging moments are positive. You might be asking yourself, just what are these axial force, shear force and bending moment diagrams Dr. Jim cares so much about? Well, they're simply graphs of the internal forces in the beam drawn on an outline of the structure. We're now up to speed on what happened in the earlier videos, so let's get on with drawing the diagrams the smart way. To do that, we need to figure out what's going on inside the beam. We will make use of the two universal truths discovered in the previous video. The first truth is that axial force and shear force diagrams are constant between loads. The second truth is bending moment diagrams are sloping straight lines between loads. These laws apply to all beams and frames, both statically determinate and statically indeterminate. They always apply. It's the law. And these truths are invaluable because they mean that we only have to calculate the internal forces at point loads. This makes drawing axial force, shear force and bending moment diagrams an awful lot easier. We don't need to worry about what's happening between point loads. It's literally a case of joining up the dots. It means that all we have to do is determine the shear and axial forces to either side of each point load and the bending moment at each point load. I'm going to work left to right across the beam, so start by drawing a free body diagram bubble that cuts the beam just to the right of A. Next, draw the free body diagram for the substructure in the bubble, remembering that the internal forces exposed by the cut will always be assumed to be positive. Also, remember that as far as the beam is concerned, the reactive forces at A and C are simply point loads. The resulting free body is so simple the unknown forces can be written down by inspection. If that's not obvious to you, write down the equations of equilibrium, noting the cut is made so close to A, the moment is zero, because all the forces have a lever arm of zero. We now have the internal forces just to the right of A, and we can plot what we have learned on the diagrams. Next, we need to find out what's happening at B. Draw a free body diagram bubble that cuts the beam just to the left of B. Whoa, not so fast. Is that the best we can do? Pause the playback and have a think about it. I hope you've concluded that the free body diagram bubble shown is suboptimal. Why? Well, it's suboptimal because although it will tell us about the bending moment at B, it will tell us nothing new about the axial force and the shear force. We know that axial force and shear force are constant between point loads, hence the axial force and shear force just to the left of B will be plus 30 kilonewtons and minus 10 kilonewtons respectively, exactly the same as at A. So let's draw a different free body diagram bubble, one that cuts the beam just to the right of B. This will give us the bending moment at B and the axial and shear forces between B and C. Genius! Again, the free body diagram is very simple, allowing us to write down the unknown forces by inspection. If that's not obvious to you, write down the equations of equilibrium. There's no shame in it. Actually, it's a great thing to do while building up confidence in your analysis skills. Before plotting the results, now is a good time to remind you of Dr. Jim's rules for drawing axial force, shear force and bending moment diagrams. 1. Always put signs on axial force and shear force diagrams. 2. Never put signs on bending moment diagrams. 3. Bending moments are always drawn on the tension side of the beam. 4. Always label the diagrams and include the units used. 5. All the diagrams must close to satisfy equilibrium. The bending moment is negative, so the tension face is on the underside of the beam and the bending moment will be drawn below the baseline. Now to C. Again, I'm going to cut the beam to the right of the point of interest. If you followed what we did at B, you should be able to figure out why. And for simplicity, I'm going to consider the substructure to the right of the cut. That is, the substructure produced by this free body diagram bubble. Cuts produce two faces, and we know from the previous video, the positive directions for the internal forces are reversed on the two cut faces. Once again, the free body diagram is so simple, the results can be written down by inspection. And these results allow us to complete the diagrams. The job's a good one. I hope you found this analysis quick and easy. Dr. Jim thinks the smart approach to drawing axial force, shear force and bending moment diagrams has many advantages. 1. It increases understanding of how structures work. 2. It's quick. 3. It minimises calculation. 4. It minimises error, because it's quick and minimises calculation, I guess. 5. It's fun, because it's intellectually stimulating. At least I think so. Your mileage may differ. If you'd like a free PDF of the key diagrams from this video, then swing by Dr. Jim's website at drjimstructures.com. In the next video of this mini-series, Dr. Jim will show you how to analyse the beam using LinPro, a free, lightweight frame analysis program. To watch the LinPro analysis video, click the link on the screen. Well, thanks for watching. If you found this video useful, please give it a like and feel free to comment on the video. Your feedback is appreciated. Bye for now. Hope to see you again soon.
Phony numbers.
If I could respond to that.
Let me just tell you what the facts are.